0.8462 has a rightmost digit of 2 in the 10,000th position. Let me just make my face a little bit smaller. There we go. So the 8 is in the 10th position, the 4 is in the 100th position, the 6 is in the 1000th position, and the 2 is in the 10,000th position. So this will become a fraction over 10,000, and the numerator will just be 8462. Now, we're technically done, but we should simplify. I'm going to simplify by the easiest thing I can see, which is dividing by 2. So our denominator will become 5,000, and our numerator will become 4231. Now, 4,231 shares no common factors with 5,000, other than 1. So that means we're finished. 0.8515 has a smallest digit, a rightmost digit of 5 in the 10,000th position, just like the last example. So again, we're going to turn this into a fraction over 10,000, and our numerator will be 8515. We're technically done, but let's simplify. I can see a common factor of 5 between the numerator and denominator. Now, I can do in my head 10,000 divided by 5 is 2,000. Just like 10 divided by 5 is 2. 8515 is a little bit harder, so I'm going to quickly use my division algorithm. 5 goes into 8 once with a remainder of 3, 5 goes into 35 7 times, 5 goes into 1 0 times, and then 5 goes into 15 3 times. So we get 1,703 over 2,000. Now there is no common factor other than 1 between these two numbers, and so we are finished. In the number 0.46, the smallest place value is the 100th position. The 4 is in the 10th position, the 6 is in the 100th. So this is equal to a fraction over 100, and in the numerator, we'll just put 46. We could write 0.46, but without that decimal place, it doesn't change the value, it's still 46. Now I can see a way to simplify this, and so we get 23 over 50, and that is our final answer. For the number 10.4934, I'm going to make my life a little bit easier by breaking it into whole numbers and decimals. So that means we're going to have 10 plus 0.4934. This means that we only have to convert the decimal part to a fraction. In the decimal part, we can see the smallest place value is the 4 in, just like the first two examples, the 10,000th position. So we will have 10 plus 4934 over 10,000. All right, let's continue. I can simplify this by dividing top and bottom by 2. So we will have 10 plus, and our denominator here will be 5,000. Our numerator is going to be 2467. And so our final answer will be 10 and 2,467 5,000ths. If we wanted to convert that into a mixed number, we would still have a denominator of 5,000, but onto the 2,464, we will add 10 times 5,000. So this will become 52,467. I think I said that number wrong before. I hope you understood what I meant. All right, and that is our final answer. Just like the last example, I can make this one a little bit easier for myself. So I could write it as 1 plus 0.9470. In fact, this 0 at the end doesn't change the number, so I can write it as just 1 plus 0.947. Now in this number, the 7 is in the thousandths position. That means we're going to have 1 plus a fraction over 1,000, where the numerator is 947. It turns out we cannot simplify this fraction, and so we are done. We can write our answer as a mixed number of 1 and 947 over 1,000, or we can write it as an improper fraction. By adding on to the 947, 1 times 1,000. So that gives us 1,947 over 1,000. Now this next example came out looking really weird. It's got a really long decimal. The reason for this is an error on my part, but it's a lucky error because we can now do two examples. We can do 2.78, and then we can also look at how we do it with all of these zeros. So let's start with 2.78. I'm going to split that into 2 and 0.78, and I'm going to convert the 0.78 to a fraction. Now, the smallest place value is the 8, which is in the hundredths position. So we will write 2 plus a fraction over 100, where the numerator is just 78. We can simplify that fraction. It's going to become 2 and 39 over 50. If we wanted to write that as a mixed number, we would add on to the numerator of 39 2 times 50. So we would get 139 over 50. So this is the final answer if we were doing 2.78. But let's have a look together at what would happen if we had that huge number. Now I've counted those zeros. There's 13 of them. Very unlucky number. So let's add in the real number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 2, 2 at the end. All right. So in this case, because the number is so big already, I don't think it saves us much hassle if we break it into 2 and 0.78000, etc. So I'm not going to bother. What I am going to do is I'm going to figure out what is this place value here. So let's have a think about it. The 7 is in the tenths position. The 8 is in the hundredths. Then we have thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths, billionths, 10 billionths, 100 billionths, trillionths, 10 trillionths, 100 trillionths, quadrillionths, 10 quadrillionths, and finally 100 quadrillionths. Okay, that's a very rare decimal to be given and asked to convert to a fraction, but we can do it anyway. So we know that our decimal has to be 100 quadrillion. So let's see, 1, 10, 100, 1,000, 10,000, 100,000, 1 million, 10 million, 100 million, 1 billion, 10 billion, 100 billion, 1 trillion, 10 trillion, 100 trillion, 1 quadrillion, 10 quadrillion, 100 quadrillion. And if we put in commas, it makes it a little bit easier to read our number. Hold on. Oh, that last comma's in the wrong place. That's why. See, commas make it easier to check what you're doing. All right, and so our numerator is going to be 278 followed by 13 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 2 2's. Okay, this is a fraction, so technically we could say we're done. But I'm going to simplify this by dividing top and bottom by 2. Now half of 100 quadrillion is going to be 50 quadrillion, just like half of 100 is 50. So 50, 50,000, 50 million, 50 billion, 50 trillion, and 50 quadrillion. Whew. Okay, halving our numerator. I'm going to do this in a way that makes sense to me as a shortcut. If you're not sure what I'm doing, you can always use your full division algorithm, but try and follow along. If we have the 2, it becomes a 1. If we have the 78, and I'm doing this together because half of 7 is 3.5, so we're going to do half of 78. That's going to be 39. Then we're going to have 13 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then half of 22 is 11. And this is our final answer. 14.648 can be broken into 14 plus 0.648. Now, we look at the 0.648 and we see that the 8 is in the thousandths position. 6 is in tenths, 4 is in hundredths, 8 is in thousandths. So this is going to become 14 plus 648 thousandths, pardon me. Now, we can simplify this fraction. It becomes 14 plus 324 over 500. We can simplify that further. 14 plus 162 over 250. We can simplify it further. It becomes 14 plus 81 over 125. Now, our final answer is therefore 14 and 81 125ths. If we wanted to convert that from a mixed number to an improper fraction, we would add on to the numerator of 81 14 times 125. Now, I like improper fractions more, so I'm going to do that. So we add 81 onto that, and we get 1381. So our final answer will be 1,831 over 125. In the number 0.2664, we have the 4 in the 10,000ths position. So this will become 2,664 10,000ths. All right, let's simplify our fraction. If we divide everything by 2, we get 1332 over 5,000. We can divide by 2 again. This is going to become 666 over 2,500. And finally, dividing by 2 once more, we get 333 over 1,250. That is our final answer. 1.14 is equal to 1 and 0.14. In this number, the 4 is in the smallest place value, which is the hundredths position. So this will become 1 plus 14 hundredths. We can divide by 2 in that fraction to give us 7 50ths. And if we wanted to make this a mixed number, it would become 57 50ths. That's our final answer. 8.1 can become 8 and 0.1. Here, the 1 is in the tenths position. So this becomes 8 and 1/10. And that's our final answer. We could also have done this without splitting it up. And so again, we'd recognize the 1 is in the tenths position. So we would get 81 over 10. And you'll notice that these two are equivalent. One is a mixed number and one is an improper fraction. I prefer to leave my answers as improper fractions, but sometimes mixed numbers are easier to understand. If I was thinking about how many glasses of water I had consumed today, it would be much easier for me to understand that I had consumed 8 and 1/10 than if I tried to think about having consumed 81 tenths. So for that purpose, a mixed number is better. An improper fraction can be much more useful, however, if we have further calculations to do, because often we would need to convert it from a mixed number into an improper fraction anyway. That's why I leave my answers as improper fractions. So we have looked at a number of different examples here. We've seen from some pretty simple ones to some absolutely insane ones. And I hope that this gives you a good understanding of how to convert decimals to fractions. Thank you for watching. Have a great day.